Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of interpreting intercepts, specifically how we can understand what they mean in a problem situation, and we'll do it in 5 minutes or less. So we have a typical graph here. We even have a little bit of a story about how this graph models the linear relationship between the gallons remaining in the leaking barrel and the time that the barrel has been leaking. What we need to do here is first identify what is the y-intercept, what is the x-intercept. But what exactly does that mean? Because sometimes in Algebra 1, you will be asked a question about interpreting what it actually means. So let's look at these intercepts real quick. So the y-intercept is where the line crosses, or in this case, meets your y-axis. That's why it's called the y-intercept. So it crosses, or in this case, meets right here. So if we wanted to give the coordinates of this, right, we would say the x is 0, because the x value of any y-intercept is always going to be 0, because that's where it crosses the y-intercept. And your y value is 5. Looks like it's crossing right there at 5. And so we might just say, in shorthand here, your y-intercept is 5, because we know that the x value is 0. What exactly does that mean? Well, it looks like this 5 is what the gallons began at. So the barrel, so we might say something like this: the barrel started with 5 gallons. Might seem kind of simple, but we need to not only just read numbers off a graph, but interpret it because we're looking at the label. So that's the gallons remaining. That's the y-axis. And so that's the starting point. As you can see, the graph doesn't extend past that into negative hours. That would be kind of weird. So that's how we would interpret that y-intercept. Let's do the same with the x-intercept. That's where it crosses the x-axis. In this case, we're just meeting the x-axis because you can't have negative gallons remaining. So you're always going to have a y value of 0, and that is going to be 10. So we can say our x-intercept is 10. We also call that the 0, the x value of the x-intercept. That's what makes when y is 0, that's the x value. So how can we interpret that? We can say it took 10 hours. These are elapsed hours. 10 hours for the barrel to drain or to empty. So that's how we would interpret that. Once it gets 10 hours, it's an empty barrel. There's nothing left to drain. Let's look at another example. So now we have the water level of a bay. It's measured several times each hour as the tide was rising. So we have a rising tide. You see we have the positive slope there. And we have a graph modeling the linear relationship between the water level and the number of hours. The water level was measured. Looks like it was measured just 4 hours right there. That's the elapsed hours. Now we just need to, in this particular problem, evaluate what is that y-intercept. So remember, it's where the line crosses the y-axis right here. And so it looks like it's at 10. So we could say that the y-intercept is 10. If we want to give the actual coordinate pair, it would be x of 0, y of 10. What exactly does that mean? Well, it looks like that the sea level is starting already at a plus 10. So the water level, looks like this was already starting before, or in the midst of the high tide there, started at 10, and this is centimeters above. And since we know that it's talking about the water level of a bay, we can say 10 centimeters above sea level. So they started measuring not at the very beginning of that high tide, but apparently there had already been a little bit of time before they started measuring, and that's what that y-intercept means.